Alright, here we go. Today we're going to be talking about the quadratic formula. So, first of all, before we can do the quadratic formula, you need to know the standard form of a parabola, and that's ax squared plus bx plus c. And we've been using that for a little bit here, and you've been using that in Algebra 1, so that's straightforward. Now, the quadratic formula is this crazy thing here. It's negative b plus minus square root b squared minus 4 times a times c, and all of that will be divided by 2a, including this piece up here in the front, and the negative b piece right there. And that formula comes from a process that actually is in a future lesson here called completing the square. And it's when you do completing the square with a generic quadratic equation like this right here. Honestly, you don't really need to know that. You need to know how to apply your quadratic formula. So next question, when should you use a quadratic formula to solve quadratic equations? I usually use these when equations aren't factorable. Now you can always use the quadratic formula, but when the equations are not factorable, this helps you get the decimal approximations for the x-intercepts or for the solutions. So now in this video here, I'm going to actually do something different here. I'm going to go out of order here just to kind of show you one of these equations that's not factorable here. So I'm going to actually skip on to C real quick. And just like the last couple of days here, we've been talking about that you need to first of all have the equation equal to 0. So we're going to subtract 9 from both sides, have it set equal to 0. You're going to label your A, B, and C values. So A is 4, B is 4, and then C is negative 9. All right, and then from there we're going to plug that into the quadratic formula up here. So that'll be negative 4 plus or minus square root. Okay, we're going to go 4 squared. Notice I'm putting parentheses around that because some people go and type this into their calculators, and you'll need your parentheses when you're typing it in, especially with negatives. All right, so 4 times 4, I guess the a value, and then times negative 9. And then all divided by 2 times your a value. Okay, and then that is basically, that's your first step there. And then from there, we're going to go ahead and start simplifying here. So negative 4, that doesn't change. We'll have 16, because that's 4 squared. And then minus 4, so basically 4 times 9 right there is 144, but then the negative 4 times the negative 9 will make it positive. So that would be positive 144 because of the negative times the negative. And that's all divided by 8. And then your next step of simplification, obviously add up the stuff inside your radical. That'll be, I guess, 160. All divided by 8. And then from here, the simplification steps here, you got to go and see if your radical can simplify from here. A lot of people want to divide the 4 and the 8, but there's an implied 1 out there in front of the radical, so you have to go and check and see if all of these numbers here are divisible by something right there. So 4, 1, and 8 are not all divisible by a number yet. So if we simplify the radical, we might be able to put a number out here that is divisible by a common number there. So just hold on a second here and you'll kind of see what I'm talking about. So as far as breaking down this radical, y'all did this in Algebra 1 here. We can say that 160 simplifies or breaks down into 16 and 10. And then 16 you can go 4 and 4. And then 4 you can go 2, 2. And then you go 2, 2 right there. And then this final 10 is 2 and 5. And with simplifying radicals, you had to look for groups of 2 or pairs of items right there. So you got a pair of 2's, you got another pair of 2's, and then you got a single 2 and a 5 left over. Okay, so then the way we write that simplified as far as a radical, we write 2 times 2, which is 4. So we'll write 4 and then square root of your leftover stuff, which is 2 times 5, which is also 10. And then if you need a little bit of extra practice with simplifying radicals, go check out. There's plenty of videos on YouTube that you can check out right there. But we're going to assume that you guys can catch on with that pretty quick and remember from Algebra 1. So anyways, we had the -4 still out there in front. So now instead of writing 1 out in front of our radical, we're writing 4 and then square root of 10. That'll be all divisible by 8, or all divided by 8. And then your final thing here to simplify is to go and see if those numbers right there are all divisible by a common number. So I see these are all divisible by 4. So then your final step for this is -1 plus or minus 1. The square root of 10, you don't do anything with that there. It's only the numbers outside the radical that you divide. Then that'll be all divided by 4. Okay. So that is your answer right there. Most of the times we'll just leave our two solutions like this. Now if you want to go and get the decimal approximation, most of the times we're not going to ask you to, but if you want to go get the decimals, this is where you split it up, I guess, into two cases. So we got to go figure out what's 1, or -1, plus 1 square root of 10, which is basically square root of 10. You don't need to write the 1 out. And then divide that answer by 4. And then you'll also go and figure out what's 1 minus square root of 10, and then divide that one by 4 right there. So square root of 10, I'm about to use my calculator here, 10 square root, it's about 3.16. So if we go, I guess, -1 and then minus 3.16, then divide that answer by 4, we can get the first decimal. So let me type that in here, -1, well, I guess that's not too hard there, that's -4.6, 4.16, I guess, and then divided by 4 gets us -1.04. So that would be your first decimal. And then I guess this other one here is going to be -1. Oh, and actually, you know what? I messed this up here. That should have been plus right there. So let's do this here. Mess this up a little bit here. So I'll change that to negative, that to positive. You can just swap your answers here. Anyways, this next one here, so -1 plus 3.16 right here. So basically, it's kind of like subtracting 1 from that. So that would be 2.16. Once we simplify, I need to write it out first. So that'd be 2.16 divided by 2. That'd be positive there, right? And then my calculator's getting out the decimal 0.54. And those are your two decimal approximations right here. So if they asked us to like round out to the nearest, two decimal places, those would be our two answers. But like I was saying, most of the times we're going to leave it like this right here. So that is that there. Now sometimes when you use quadratic formula up here, sometimes these you can factor the problems from the beginning. So like I think A here, we're going to be able to factor it pretty easy, but I'm going to go and show you what it looks like plugging into the quadratic formula. The reason being here, I want you to get in your head that you can use the quadratic formula to solve any type of problem ever. That is dealing with quadratics, I guess. So first of all, we're going to add the 4 to the other side. So that equals 0. Okay, we're going to label our A, B's, and C's. So A is 1, B is 4, C is 4. Okay, and then we're going to go plug into the quadratic formula, -b. So -4 plus or minus square root 4 squared minus 4 times A times your C value 4, all divided by 2 times 1. So I'm just plugging into that formula right there. Okay, so that's -4 plus or minus 4 squared, I guess this is going to be 16 there, and then minus 4 times 4 is also 16 right there, and all divided by 2. So this one's kind of significant here because inside the radical you're just going to get plus or minus square root of 0, which that basically turns into the square root of 0 is 0, so 4 plus or minus 0 divided by 2. And then if you add or subtract 0, that doesn't change anything. So that'd be just -4 over 2, which then comes out to -2 as an answer. Okay, so that means x is only one answer there. It's only -2. And just to show you here real quick, you can take this same equation. You can also solve by factoring. And I think that would be actually a little bit easier on this one here. But when you solve by factoring, you should get the same exact answer. So I'm just going to work that out. You don't have to write this down, but this is just to verify you get the same thing. So when we factor this, this will be x plus 2 and then x plus 2 and equals 0. And then you split it up into your two cases, x plus 2 equals 0, x plus 2 equals 0. So x equals negative 2 and negative 2, which is a repeated answer. So really you only need to write it once. But notice here we got the same exact thing there. So quadratic formula, if you don't know like what method is the best way to solve a quadratic formula, will always work. Okay, so let's try out one more here. All right, for this next one here, we'll go ahead and set, we'll say A is 2. It's already set equal to 0, so we get to start right away. B is negative 1, and then C is negative 15. And then we'll go into our quadratic formula. This will be negative 1, which will eventually change that to a positive. We'll go negative 1 squared, and then minus 4 times A times C. And then all divided by 2 times A, or 2 times 2 right there. Negative 1 will be positive. 1 squared will be 1, and then negative 4 times 2 times negative 15 will be 120 right there, because the two negatives will cancel, and all divided by 4. Okay, and then after that, obviously, you get square root of 121, which actually is a perfect square, so this would be 1 plus or minus 11 divided by 4. And then kind of like the problem that we did the first one with the decimal here, we're going to split this up into our two cases and say 1 plus 11 divided by 4 is one of the cases, and then 1 minus 11 divided by 4 will be the other case. So 1 plus 11 is going to be 12, and then 12 divided by 4 is going to be 3. And then 1 minus 11 will be negative 10. So negative 10 over 4 will reduce down to, I guess, negative 5 over 2. And those will be your two answers right there for that. So simplifies a little bit. Honestly, when they don't simplify, to me, they're a little bit easier because you have less steps to worry about. So, all right, let's see what's going on here with this next one here. Your school's jazz band is selling CDs at price X as a fundraiser. The total profit P is modeled by P equals negative X squared plus 48X minus 300. What is the least amount in dollars that you can charge for a CD to make $100 profit? So I guess we're going to plug in 100 in for the other side here, and then we'll write the rest of it out. Okay. Next, we're going to add over, or I guess subtract over the 100. That'll be negative 400. And then just a good little rule of thumb here, life is a little bit easier if x squared is positive. So I'm going to divide everything by negative 1, which basically flips all of our signs around. And that's going to make the problem kind of be a little bit easier here towards the end when we do our quadratic formula. So my b is negative 48, so that'd be negative 48. And then plus or minus. And then I guess negative 48 squared. And then plus, or actually, I'm sorry, minus 4 times 1 and times 400. And all divided by 2 times your a value, which is 1. Okay. And then I gotta get my calculator going here, so bear with me. Negative 48 obviously is positive 48. And then 48 squared comes out to 2,304. And then, did I miss something here? No, I didn't. Okay, and then minus 1,600. I guess 4 times 400. And then all divided by 2. I guess I'm running out of room here, so here I'm going to write it up here, kind of towards the top. So obviously 48 plus or minus, I think when you subtract the 2 inside the radical, you get 704. And I do not think that's a perfect square. So I'm going to use my calculator to get the decimal for 704. Of course, I'm on my phone, so it's a little bit trickier. Gotta wait here a second. Okay, so that'll be the decimal. I'll go 26, and I'm gonna go out 2 decimal places. So 26.53, and then divide it by 2. Okay. So then now from here, this is kind of like the very first problem where you split it up and you do your two different decimal values to figure out what you need to charge here. So I guess we'll do 48 minus 26.53, and then we'll divide that by 2, and apparently that gets us 10.735. And then let me do the other case where you subtract. So that's 48 minus 26.53. Oh, I think I already did that. I need to add. I'm sorry. So 48 plus 26.53. Divide that by 2. Apparently that's getting me 37.265 right there. Okay, and then I guess those are your two different ones there that you can charge to figure out, to make the profit right there. So you will make $100 profit if you charge either of those prices. And obviously, if it's a price, it's probably good if you go and switch that there to 70, $10 and 74 cents, or you can do $37 and then 26 or 27 cents right there. I think the answer X was in, yeah, X was the price there. Now, obviously, if you're doing CDs, if you kind of use logic here, the $37 and 27 cents right there is probably not a realistic price for a CD, so it's probably going to be this price is the best option, but that is, what you need to do there on that. So, okay, next page here is dealing with something we call the discriminant. It's a piece of the quadratic formula. It's everything that's inside the radical. And everything inside the radical can help determine what type of solutions that you're going to have, if you're going to have rational or irrational solutions, and then also, if they're, positive or, real or not real. So in the quadratic formula, we call this thing the discriminant. Up there at the top is also written up there. All right. So if your discriminant is positive, which that means, is greater than 0 right there, that means you're going to have, usually you're going to have two solutions. And these solutions are going to be real solutions. Because here in this unit, we're going to talk about what happens when you don't get real solutions. We kind of focus on it a little bit later on, but all right, whenever it is equal to 0 right here, you're going to say that you get exactly one solution. Okay, and then whenever it is negative right here, there are no real solutions, which means we get two imaginary solutions. And we could really get into imaginary solutions a little bit later on in this unit here. I think it's maybe 5.9. I can't remember what section it is off the top of my head. But so bear with us on that there. So for right now, just know there are no real solutions or two imaginary solutions for that. Now, if you were to graph what two solutions looks like, we need to just graph something with two x-intercepts. It can go up, it can go down, it doesn't matter. Something with two x-intercepts. All right, so obviously something with one solution needs to have one x-intercept, so where it just barely touches and turns back around. Oh, there you go. Okay, and then no solutions just means it doesn't cross your x-axis at all. Doesn't matter which way it's opening, if it's opening up or down. So yeah, it can kind of just speed up the process and see if the problem's even worth solving. I think here in a minute we're gonna do a discriminant word problem here where we can use the determinant to determine if there's anything worth solving for. So anyways, first of all, I guess here they asked us to find the discriminant of each. Remember that's the b squared minus 4ac. So in this case here, it's pretty much all the same stuff we just did on the previous page here. So we'll do 2 squared, or 10 squared, minus 4 times a, which is 1, and times c, which is 23. Okay, so then this looks like this will be 100. 4 times 23, I think it'll be 90 something, 92, I believe. And then, yeah, obviously that comes out to 8 right there. That's your discriminant. And based off your discriminant, since it's positive, that means you have 2 solutions in this case. So even though they didn't have a line for that, go ahead and write the fact that there's 2 solutions there. Okay, let's see what the determinant is here on this and what it means. Like when you're solving, you need to have everything equal to 0. So I'm going to subtract over 9x and add 11, and equal it to 0. And then we'll go negative 9 squared for b squared. So b squared minus 4 times 8 times c, which is 11 right there. Obviously, that's a big number there. 81 minus, and I'll have to use my calculator here, I guess 32 essentially times 11. And that comes out to negative 352. Okay, and then I guess if we do 81 minus 352, it gets us negative 271. And really, if you realize it's negative right away, you can pretty much go ahead and make the conclusion that you're not going to have any solutions here. So you would say 2 imaginary solutions, or you can even say no real solutions. That is it there on that. So these other 2 problems, pretty much the same thing here. I guess they, have us write it out here. So we'll just quickly do these here. So negative 3 squared minus 4 times 2 times 7. So that's 9 minus, what is that, 8 times 7, so 9 minus 56 right there. So it's kind of like subtraction there. So what is that? Negative 47 right there. So obviously that means you're going to have 2 imaginary solutions because the determinant was negative. And use this chart above here. If it's negative, right here, 2 imaginary solutions. If it's positive, 2 real solutions. If it's equal to 0, you just say it's a 1 real solution. I guess I probably should write that here, 1 real solution. Okay, and then from here, let's see what's going on with this one here. X squared minus 6x minus 5 equals 0. Negative b, so negative 6 squared minus 4 times a, and then times c, which is negative 5. So that's 36, and then I guess plus 20. So I guess that'll be 56. That's positive right there. So that means there will be 2 solutions that are real. So I guess with these examples here, we didn't see one where you actually got equals to 0. So whenever you see that, if the b squared, and you do the minus 4ac, if those cancel out and you get 0, then you're going to say that that is 1 real solution. So just be on the lookout for that. I know that didn't happen here, but that is that there. So this last one's kind of a weird one here. Instead of actually solving it, we're going to use the discriminant to go and actually see if something has a solution or not. So with this here, the height of a golf ball at any given time as it travels through the air is given by this equation right here. Without solving the equation, will the golf ball reach 110 feet? So we're going to plug in 110. And then get all this ready here, I guess, plus the fraction 1/12 there, which is kind of like your y-intercept. I guess it's an inch, I guess, off of the ground. Okay, and then from here we'll subtract over the 100. Still starts out the same, still needed equal to 0. If we subtract 110 there, I guess that'll be 109. And then whatever the decimal is for 11 over 12 right there. And you could use your calculator to get the decimal for that. That's probably the best. 11 over 12 is actually the decimal. I guess 9.16 repeating. Kind of like that right there. So obviously not a pretty decimal there, but that's that. Okay, and then if we use the determinant, if we use the b squared minus 4ac, we can see if it hits 100 based off of if there are solutions for this. If there is no solution, then that means it'll never hit 100. So basically, we're going to just see if b squared minus 4ac, we're just going to see, whoops, if that is a positive number. That's really all we're checking for. Is it a positive? Or even if it's equal to 0, then that means there's at least one solution. So anyways, let's try this out here. So this is 85 squared minus 4. A is negative 16. And then I guess C here is negative 109. I'm just going to round that to 0.9 because that 0.16 probably isn't going to make that big of a difference. Maybe it will. Not sure. So 85 squared, if I type it right here, my thumbs don't mess me up here, that's 7,225. And 4 times 16 times 109.9. It's basically 7,033 and then 0.6. And obviously when you subtract those two, it's going to become a positive number. 191.4 right there. Obviously that's greater than 0 right there, so that means there are two solutions. Or in the context of our situations, that means there are 2 times on this graph that the ball is at 110 feet. Honestly, it'd probably just be best to solve for those values anyways and actually figure out what they are using negative b over negative b plus minus square root of b squared minus 4ac, just doing that instead. But this is, just kind of showing you can use the determinant, the b squared minus 4ac, you can determine if it was going to have solutions or not. So, and that is about it there.